Hello everyone, welcome back to my YouTube channel where we try to make maths fun and understandable, or at least manageable. We are back again with Form 2 KSSM, Chapter 2, where we will be covering factors, prime factors, HCF and LCM. If all of those terms seem new to you, just bear with me. I will walk you through them one by one. Firstly, we have to understand what does the term factors mean. Factors are the numbers which are able to divide another number without any remainder. Or simply put, a number divisible by another number. This other number will be the factor of the number right here. Or in simpler words, this number right here, let's assume it's x, will appear in the multiplication table of this another number, which we can assume as y. Pardon my phone's notification. So to give you an example, let's take a number, for example, 18. 18, in this circumstance, we assume it to be the number, which is x. Then another number will be 2. So can we say that 18 is a factor of 2? No, it's the other way around. 2 is the factor of 18 because 18 is completely divisible by 2 without any remainders, and 18 appears in the multiplication 2 timetable. That's the basic understanding of factors. So in examinations, you will most probably be asked what are the factors of a particular number. Let me give an example. For instance, the number given is 24. And you are asked to list out all the factors of 24. So the rule of thumb is to start with the number 1, because as we know, all the real numbers are divisible by the number 1. And it's also a good practice to write down 24 at the end of the list, because as we know, any number, as long as it's a real number, it is divisible by the number 1 and also by itself. In this case, 1 and 24. Then after this, I have, it's not much of a technique, it's a logic that I follow to make sure that I get all of the factors. So after 1, as we move on, the next integer will be number 2. And as we know, 24 is an even number, it is divisible by 2. But instead of going to the next next integer in the ascending order, what I tend to do is I try to see what times 2 will get me 24. 2 times what? 2 times what gives me 24. So what I do is I take 24 divided by 2 and I get 12, which will be the second last number. Do you see the pattern? Then after 1, 2, next we have 3. So since we know that 24 is divisible by 3, let's see, 3 times what gives me 24? 3 times 8 gives us 24. That 8 becomes the third last factor of this list. Then let's move on. After 3, we have 4. As we know, 24 is also divisible by 4. So here we have 4. Then the same rule applies. 4 times what gives us 24? 4 times 6. So 6 goes right here, and that becomes the fourth last number. And then 5, as we know, is not divisible. 24 is not divisible by 5. So there we go. We have our entire list: 1, 2, 3, 4, 6, 8, 12, and 24. So in essence, what you should have is a list of numbers, all of the numbers which are the factors of 24, which means 24 is divisible completely without any remainder by all of these numbers. To verify whether you have gotten all the factors, you can do something like this. You can try drawing what I like to call rainbows, where 1 and 24 will make up 24. 1 times 24. Then next we have 2 times 2 times 12, where we get 24. Then 3 times 8, where we get 24 again. Then 6 times 4, where we still get 24. So by doing this, we know that each number has its own pair, and by having a complete rainbow, it's safe to say that we have covered all of the factors for this particular number. Let's try one more example, and this time you can do it along with me. If you want to give it a try, you can pause the video anytime and try to do it. The number is 35. And let's begin. So for 35, as I said, the rule of thumb is to start with number 1 and also itself. 1 and 35. Let's go through the list. We have 35 not divisible by 2, not divisible by 3, not divisible by 4. It is divisible by 5 because it ends with 5, so we know that it's divisible by 5. So 5 times what gives you 35? 5 times what gives you 35? The answer is 7, so that becomes the second last digit, the second last factor. Then 5, 6, 7. As you see, after 6 we have already passed the number 7. So this means that we have already gotten to the maximum number of factors that is possible for that particular number. So it's safe to say that for 35, these 4 are the factors. As simple as that. Now that we have covered factors, and for those who don't get it, try rewatching this part again and try to do it with other numbers so that you get a feel for it. Now that we have covered factors, it's time to move on to the next term, which is prime factors. To know prime factors, it's important to understand what does the term prime actually means. So as we know, factors are the numbers, as we have covered earlier, factors are the numbers which can divide a number perfectly without any remainder. But what does the word prime means? The word prime refers to a number. Well, all the terms refer to a number. Okay, a prime refers to a number that is only, this number is only divisible by 1, by the number 1, and also by itself. A number that is only divisible by 1 and itself is known as prime numbers. To give an example, for example, we have the number 5. Is 5 a prime number? Let's check it out. Let's test it out. Firstly, for 5, we can be divided by 1. And the next number, 2, 3, 4, none of them are possible. So we end up with the number 5 again. So 5 is a classic example of a prime number because it's only divisible by the number 1 and by 5. And 2 important things to note here is the number 1 is not considered a prime number, as it's a standard requirement for a number to be prime. So we do not consider 1 as a prime number. And the number 2, although it's an even number which we may think is not a prime number, it actually is, because 2 is divisible by 1 and 2 is divisible by itself. So by definition, 2 is a prime number because it is only divisible by the number 1 and by itself. And 2 is the smallest prime number you can ever have, the lowest possible prime number in existence. And that's the meaning of prime. So what does the term prime factors mean? Once you understand prime numbers, prime factors becomes much easier. Prime factors refers to the factors of a number that are prime numbers. So to take the example from our previous question, when we have the factors 35 as 1, 5, 7 and 35, to find prime factors of this particular number, first list out all the factors 1, 5, 7, 35 and then pick out the prime numbers. So as we said, 1 is not a prime number, 5 is a prime number because it is only divisible by 1 and 5, and 7 is also a prime number because it is divisible by 1 and by itself, which is 7. So 7 is also a prime number. And is 35 prime number? Of course not, because what we have written here says that 35 has factors 1, 5, 7, 35. It has 2 more factors than itself and 1. So 35 is not a prime number. So the prime factors of 35 will be 5 and 7. As simple as that. This subtopic about prime factors is mostly about understanding what prime numbers actually mean, so that you can pick out the prime numbers from the factors of a number. So prime factors, all you have to do is list out all the factors regardless whether they are prime or not. List out all the factors, and then among the factors, select the ones that are prime numbers. And that's all about prime factors. Now let's move on to the special terms of this chapter. We have the term HCF and LCM. HCF and LCM is one of the most common concepts you will be tested in your examinations. And these two are techniques, by the way. These techniques will be used mostly to solve real life questions, which I will be covering in a separate video that requires the whole other video. But in this video, I will be teaching you how this concept actually works and how to do the working steps, so that when we attempt actual questions, you would have a better understanding of what goes where and what happens here and there. Let's begin with the first one, HCF, which is an abbreviation for highest common factor. If you have seen in textbooks, you will realize that there are some ways to do this, specific ways. But before going into the ways of doing it, let me clarify what it actually means and how to do it from a logical standpoint. Because in mathematics, it's important to understand the logic behind a certain working step before diving into the mathematical way of doing it. Mathematical way of doing it, you must understand, it's not always logical. It's all about simplification. when we attempt a question using mathematical way that we don't understand, it's no point actually, because we will not be able to replicate or do it again in another scenario. We are just bounded to that one particular scenario. So it's important to understand how something works, especially in maths, how something works, in order for us to do this, apply the same logic, apply the same concept to solve another question that has the same, that requires the same foundational background. All right, let's begin. For highest common factors, it's exactly as what it says, the highest common factors between two numbers. So let's not deviate too much from our example. So let's take 24 and 35. The rule applies here as well. For each and every step, try to list out all the factors. For 24, we have 1, 2, 3, 6, 8, 8, 12, 24. And for 35, we have 1, 3, 5, and 35. Is that correct? I'm pretty sure some of you with sharp eyes would have noticed there are two mistakes with this list. And if you have managed to figure it out, congrats. So here I missed number 4. It is 1, 2, 3, 4, 6, 8, 12, and 24. If you were ever confused whether you are completely correct, you can always use the rainbow method. 1, 24, 2, 12, 3, 8, 4, 16. Then for 35, the other mistake is that it's not 3, it is 7. So 5 will go about right here, and then 7 will go right here. So the highest common factors, as the term clearly says, they are asking for the highest common factors. So what does common factors mean? Common factors means the factors that exist in both the list of factors of both numbers. So for 24 and 35, when we see the list of factors, the common factors are the ones that appear in both. That's the definition of common factors. I did not go too much detail into the concept of common factors because it's quite obvious. Common factors are the factors that appear in both the list of numbers, in both list of factors of particular numbers. Common factors can be between 2 numbers, 3 numbers, 4 numbers, 5 numbers, according to the question. But common factors are just the numbers that appear in all of the lists of the given question. So here we have common factors. So for this particular question, the common factors are just 1. So the highest common factor can only be 1 because that's the only possible number. This might not be the perfect example. So let me give you another one. So let's take, for example, 28 and 24. So for 28, let's begin. The same concept applies. So the first step, list out all the factors. So listing all the factors means let's start with 1. Then 1 means 28. And after that 2, which means 14. Then 3, no, and then we have 4, which means 7. Then 5, 6, 7, and then we have back to 7. That means we have completed the cycle. 1, 2, 4, 7, 14, 28. And let's move on to 24. 24, we have 1, 2, okay, 1, 2. Let's not forget the rainbow method. So 1 means 24, 2 means 12, then we have 3, which means 8, and 4, which means 6. So 1, 2, 3, 4, 6, 8, 12, 24. So the first step is done. List out all the factors. And also, just a reminder, to verify, always go back to the rainbow method to make sure all the factors are here. Now that the first step is over, the second step is list out all the common factors. Common factors are the factors, as I said earlier, that appear in both the list. So in both of this list, the common factors are, firstly we have 1 appears in both, then we have 2 which appears in both, then we have 4 which appears in both, and after 4, that's it. So the common factors of the number 24 and 28 are 1, 2, 4. And then the third step after finding out the common factors is find the highest. Find the highest. So 1, 2, 4, which one is the highest one? So 1, 2, 4, the highest one would obviously be 4. So what we are trying to say is the HCF of 24 and 28 will be 4. That's it. The highest common factor. Just follow these 3 simple steps and you will be getting the HCF immediately. Alright, this is the understanding part of it, how it works. This is one way of doing it. You can actually use this method for examinations and it's completely fine. But the problem arises when the numbers are too big to list out all the factors, which might consume too much time during the examination. So what we do here, what KSSM syllabus tells us to do, is to use something called the repeated division method. So what we do is we write out 24 together 28. Then we draw this partition which represents divide. Then we try to divide these two numbers by a common number, by a common factor. So we are going to see 24 and 28. Both of these numbers can be divided by the number. Let's get to as slow as possible. Don't use 1 because you just get back the same number. Let's use 2. So when we use 2, we will get back 24 divided by 2, we have 12. 28 divided by 2, we have 14. Then 12 and 14 are also divisible by the number 2. So let's just stick with 2. 12 divided by 2, we have 6. And 14 divided by 2, we have 7. Then 6 and 7, we are not able to divide both of them by any number. 6 and 7 are not in any multiplication table. So therefore, we can't use them. They're only available in 1, but dividing by 1 is, there's no point to it. So here we have 2 and 2. So what we do is, we times all of the numbers on the left hand side. So in this case, we have 2 times 2, which gets us the answer of 4. So 4 is the HCF of 24 and 28. So what you see at the top here is the logical standpoint of how to do this question. And the bottom one is the repeated division method, which is also logical, but it's in a much more simplified manner. And that's all for HCF, highest common factor. I hope that you understand. If you don't understand, be sure to go back to try to watch the video one more time. If you still can't understand, feel free to email me any of your questions and I would be happy to answer them. And if the questions are difficult enough or interesting enough, I would be showing them in another video, trying to answer it live. So now that we are done with HCF, common factors, prime factors and everything, it's time to jump into LCM, which stands for lowest common multiple. But before going there, it's important for us to understand what does the word multiple actually mean. So here we are going to the second big subtopic of this chapter, multiples. So what are multiples? So multiples are, simply put, is the multiplication table where we just have the answers. So for instance, if I ask you the multiples of 3, you would recite the entire multiplication 3 table to me, which is 3, 6, 9, 12, 15, 18, 21, and so on. It's never ending, it's forever. This is what we call multiples. As simple as that. It's just a multiplication table all over again. And then the same concept here, concept applies here. Common multiples. And for those wondering, we do not have prime multiples. It doesn't work that way because a number cannot be prime if it's a multiple. For example, if we can't say 7 is a multiple of anything because 7 is a prime number. Prime numbers cannot be a multiple of a number. Multiple of a number means that multiple of 3, which is 6, which means that 3 is a factor of 6. You must understand that just like times and divide, plus and minus, multiple and factors are opposites. They complement each other in the opposite manner. It's important to have that understanding. And an important thing to note here is, when you're trying to understand a topic, try to see how they relate to each other. Just don't try to brute force yourself through just understanding the parts. It's important for you to see the bigger picture and see how they relate to each other. 3 is a factor of 6 and 6 is a multiple of 3. Both of those statements are true. I will repeat, 3 is a factor of 6 and 6 is a multiple of 3. Try to give it some thought and you'll understand what I mean. There are no prime multiples, but we have common multiples. So common multiples very similar to common factors. Common multiples are the multiples that two numbers share. For example, we have multiples of 3 here. Let me quickly write the multiples of 6 as well. Multiples of 6, which start with 6, 12, 18, 24, and so on. So here we have the common multiples, which means the multiples that appear in both the list. So we have 6, then we have 12, then we have 18, and then we have a lot more to go. So, but these are the common multiples of these two lists. So it's safe to say the common multiples of 3 and 6 are 6, 12, 18, and so on. So that's the concept of common multiples. Now that we have an understanding of what multiples are and what common multiples are, let's take a look at LCM, which is the abbreviated form of lowest common multiple. The rules for this and also for the highest common factors are very, very similar. It's just that for that we are finding the highest common factor, the highest factor. But here we are going to find the lowest common multiple, which is the lowest multiple, the lowest number. So we're going to use the exact same example. We have multiples of 3 and multiples of 6. And if we list it out, we have 3, 6, 9, 12, dot dot dot, and then for 6 we will have 6, 6, 12, 18, and so on. So if you were to list out the common multiples, we will have common multiples of 6. We will have of 3 and 6. We will have 6, and then 12, and so on. So once you have the list of common multiples, to find the lowest common multiple, it's clearly stated lowest. Lowest means see the least number there. So we have 6, 12. So obviously 6 is the smaller number. Therefore, 6 will be considered the LCM of 3 and 6. Let's continue to using the repeated division method for lowest common multiple. For repeated division, it's very similar to what we did for HCF, but instead here they're going to go much further. So we have 3 and 6, then that's divided by the same thing divided by a number that can divide both the numbers first. So we have 3 divided by 3 is 1, and 6 divided by 3 is 2. So we have 1 and 2. Now once you get 1, you don't have to worry about that part. So we have 2, right? So for 2 can be divided by itself, which is 2. So we just go on, and this time you don't have to divide 1 by 2, because 1 divided by 2 is, you don't have to go to the fractions. So once you get to 1, you can neglect that part and just focus on the part that still has a number which is not 1. So 2 divided by 2, we will get 1. So 1, 1. So that means we already have, when we are down to 1, 1, that's it. The calculation is over. So the same thing applies here. We have to take the product of all the numbers on the left hand side. So we have 3 and 2. 3 times 2 is 6. 6 is the LCM. 6 is the LCM of 3 and 6. Repeated division for LCM. So this is the logical part of it, like how what it actually means and how it actually works. And this is the mathematical way of doing it. So for exams, it's important that you use repeated division to save yourself time, unless the question demands you to list out all the factors and find using the manual way. If they don't specify that, it's always better to use repeated division, as it will save you lots of time, which can be used to check the answers at the end of the exam before you hand in. Therefore, it's important that you understand both of these methods, as in examinations you might be asked to use one of them specifically. And that's all for factors and multiples. So in the next video, or in the subsequent video that is a sequel to this video, I will be attempting a few LCM and HCF questions so that you can understand the application of LCM and HCF and in which situations should you actually use them. I kid you not, this concept, although it may seem very simple, at times it can be confusing because the questions that are given are quite twisted, that it takes a bit of time to actually understand what the questions entail. But that's the topic for another video. So for this video, thanks for watching, and I will see you in the next one. Till then, maths is fun. Just remember that. Thank you.